So now in the previous example, we saw what we needed to do to find an inverse of a given relation. And in the case of sample problem number 1, we were given a linear function. And if you notice that the inverse also becomes a function. It's another linear function. So we would call the inverse a function as well. Now, sometimes you'll be asked to find a given inverse, such as in the previous sample problem where we gave you a function, we asked you to find the inverse of the function. However, sometimes you will be given two random functions and you'll be asked to determine if they are inverses of each other. Now, many students will just take one of them and find the inverse of it and see if it matches up with the second one. However, we have a different mathematical version of how to do this. And if you look at the key concept in this image right here, if you take the composite functions of the two given functions, the function and its implied inverse, then what you'll have is each composite function will actually come out to equal x. And then for all intents and purposes, this shows us that a function and its composite of its inverse creates the identity function. So anytime we ask you to verify, so if we use the words verify the function and its inverse, what we're really looking for you to do is to use composite functions as opposed to finding the inverse of one and matching it up with the other. So we'll take a look at a problem like that, and you can see example 2. It says verify that these two functions are inverses of each other. You can see the solution gives us the composite functions of those, and they both equal to x. And that's a very important part of this. So that tells us that they are inverses of each other. Now notice this process that kind of happens right here. We end up getting this canceling out effect, if you will, and that's telltale sign of when you're dealing with inverses, because one of the functions undoes the operations of the other function, and that's what's implied with the inverse. So if you take a look, sample problem 2, we ask you to verify that these are inverses of each other using composition of functions. So go ahead and take a look at that now and come back and look at the solution. Okay, so I'm just going to simply set up the composition of functions for both sides of this, and let's see what it comes out to be. Okay, so you can see I have my two composite functions here, and both of them ended up equaling to x, which creates an identity. And so we can say, since they're both equal to x, that these two functions are inverses of each other. Now, notice we use the function notation here, f of -1 of x, to represent the inverse, but it may not always be like that. So, alright, good example of verifying inverses.